Hello everyone, welcome to my channel. So today in this video we're going to start the second chapter, that is polynomials. So in this chapter we'll see what are polynomials, what is the degree of the polynomial, types of polynomial, zero of a polynomial and value of a polynomial. So before starting with this chapter, we'll have an introduction. So first we see what is this polynomial. An algebraic expression in the form of a0 plus a1x plus a2x square plus up to so on an x to the power of n, where a0, a1, a2 and so on an are the real numbers and your n is a non-negative integer and an, which is not equals to 0, is called a polynomial of degree n. So here a0, a1, a2, a3 and up to so on an are the real numbers and it is also called as numerical coefficient and it has the highest power is n. Next we see degree of a polynomial. The highest power of variable x in a polynomial p of x is called the degree of the polynomial. Suppose I'll take one example, this p of x which is equals to x and here its degree is 1. Next we see the types of polynomial. So the first is the constant polynomial. A polynomial of degree 0 is called a constant polynomial and it is of the form p of x which is equals to k and here its degree x power 0, k into x power 0, x power 0 is 1. So here its degree is going to be 0. So p of x which is equals to k, here k is a constant. For example 4. So it is a constant polynomial. So next type is linear polynomial. A polynomial of degree 1 is called a linear polynomial and it is of the form p of x is equals to ax plus b. Here a and b are the real numbers and a which is not equals to 0. Example for linear polynomial is 5x minus 3. Here x power is 1 and here its degree is 1. Next is the quadratic polynomial. A polynomial of degree 2 is called as quadratic polynomial and it is of the form p of x is equals to ax square plus bx plus c, where a, b and c are the real numbers and a which is not equals to 0. Example for quadratic polynomial is 2x square plus 9x minus 5. Here x power x, here x degree is 2. Next is the cubic polynomial. A polynomial of degree 3 is called as cubic polynomial and it is of the form p of x is equals to ax cube plus bx square plus cx plus d, where a, b, c and d are the real numbers and here a which is not equals to 0. Example for cubic polynomial is 3x cube plus 4x square minus 5x plus 10. Next type is biquadratic polynomial. A polynomial of degree 4 is called as biquadratic polynomial and it is of the form p of x is equals to ax power 4 plus bx cube plus cx square plus dx plus e, where a, b, c, d and e are the real numbers and here a which is not equals to 0. So next is value of polynomial. If p of x is a polynomial in the form of p of x is equals to a0 plus a1x plus a2x square plus up to so on an x to the power of n, where an which is not equals to 0, then value of polynomial p of x for a real number value at x is equals to alpha. Here p of x is a polynomial in x and alpha is any real number. Then the value obtained by putting x is equals to alpha in p of x and is given by here x is replaced by alpha. So p of alpha is equals to a0 plus a1 of alpha plus a2 of alpha square plus a3 alpha cube and so on an alpha to the power of n. So let's take one example here, that is p of x is equals to 2x minus 3. Find the value of a polynomial if x is equals to 3. Now I put x is equals to 3 here. So p of x, replace, just put x is equals to 3. So p of 3 is equals to 2 into, so in place of x write 3 here, 2 into 3 minus 3 which is equals to 2 3s are 6 minus 3 which is equals to 6 minus 3 is 3. Next, 0 of a polynomial. If p of x is a polynomial, 0 of the polynomial are those values of x which make the polynomial 0. So let's take one example here. So p of x is equals to x minus 4. Now we need to find the zeros of the polynomial. Then we need to equate the polynomial to be 0 here. That is p of x is equals to 0. So x minus 4 is equals to 0. So x will be 4. So here 4 is the 0 of a polynomial. When I substitute this x is equals to 4 in this polynomial, I will get p of x, that is p of x is equals to 0. So p of x will be 0 here. So let's take another example, that is p of x is equals to 3x square minus x minus 4. Here we need to find the zeros of a polynomial. Now to find the zeros of a polynomial, we equate this polynomial to 0. So if p of x is equals to 0, then 3x square minus x minus 4 is equals to 0. And it is a quadratic polynomial. We need to factorize this. So now to factorize this, the coefficient of x square is 3. We multiply 3 into 4 is 12. 3 into minus 4. 3 into minus 4 is minus 12. When we multiply, we should get minus 12 and we add, and when we add, we should get minus 1 here. So what are the factors of minus 12? That is 4 3s are 12. Minus, since here we have minus 12, so 4 3s are 12, and when we add, we should get minus 1 here. So here bigger number is 4. So for this I'll take negative sign, and for this 3 I'll take positive sign. Minus 4 into 3 will be minus 12. So 3x square minus 4x plus 3x minus 4 is equals to 0. So here in these two terms, I'll take x as common here. So x into 3x minus 4 plus, here I'll take 1 as common. So 3x minus 4 is equals to 0. So in these two terms, Like 3x minus 4 I'll take as common. 3x minus 4 and the remaining will be x plus 1. So x plus 1 into 3x minus 4 is equals to 0. X plus 1 is equals to 0 or 3x minus 4 is equals to 0. So x is equals to minus 1 and 3x minus 4 is equal 3x is equals to 4. So x is equals to 4 by 3.
Minus 1 and 4 by 3 are the zeros of the polynomial.
Now let's see the next concept, that is relation between zeros and coefficient. So for the linear polynomial, the standard form of the linear polynomial is p of x is equals to ax plus b. Here a which is not equals to 0. Now let's see the next concept, that is relation between zeros and coefficient. First is the linear polynomial. So the standard form of the linear polynomial is p of x is equals to ax plus b. Here where a which is not equals to 0. Now what is the 0 of the polynomial? So let me assume it as k. Here k is the 0 of the polynomial. So we'll replace x by k here. So p of k is equals to a of k plus b. When I equate this with 0, a of k plus b is equals to 0. I'll send this b to this side. So a of k is equals to minus b. Therefore k is equals to minus b by a. So which is equals to minus 1 to the power of 1. So here b is the constant term divided by, and here a is the coefficient of x. Next is the quadratic polynomial. Now the standard form of the quadratic polynomial is given by p of x is equals to ax square plus bx plus c, where a which is not equals to 0. Let alpha and beta are the zeros of the polynomial. Then the sum of zeros, that is alpha plus beta is equals to minus b by a, which is equals to minus 1 to the power of 1. Here b is the coefficient of x divided by a is the coefficient of x square. Next, product of zeros, alpha beta is equals to c by a, which is equals to minus 1 whole square into constant term. C is the constant term divided by, here a is the coefficient of x square. Next, for cubic polynomial, the standard form for the cubic polynomial is p of x is equals to ax cube plus bx square plus cx plus d, where a which is not equals to 0. Here let alpha, comma, beta and gamma are the zeros of the polynomial. Then sum of zeros is alpha plus beta plus gamma is equals to minus b by a, which is equals to minus 1 to the power of 1 into coefficient of, here b is coefficient of x square divided by a is coefficient of x cube. Next is product of zeros, alpha, beta, gamma, which is equals to c by a, which is equals to minus 1 whole square coefficient of x divided by coefficient of x cube. So here coefficient of c is coefficient of x divided by a is coefficient of x cube. Next, sum of the product of zeros taken 2 at a time. Sum of the product of zeros taken 2 at a time. So alpha beta plus beta gamma plus gamma alpha is equals to minus d by a, which is equals to minus 1 cube. Here d D is constant divided by coefficient. A is coefficient of x cube. So this is the relationship between zeros and coefficient. In your exercise, there will be one type of question where sum of zeros and product of zeros is given. So find the polynomial. So there is a formula, that is P of x is equals to x square minus alpha plus beta into x plus alpha beta. So here alpha plus beta is sum of zeros and alpha beta is product of zeros. So if you substitute sum of zeros and product of zeros, you get a quadratic polynomial. So next concept is geometrical meaning of zeros of polynomial. If you draw the graph of P of x is equals to 0, then values where the curve cuts the x-axis are called zeros of the polynomial. First we see for the linear polynomial. So for the linear polynomial, the graph is going to be a straight line. So that line where it intersects the x-axis or cuts the x-axis, that line is called the zeros of the polynomial. So here like I have drawn two graphs here. So this is x-axis and this is y-axis. Here the line intersects at x is equals to 2 and it is cutting at 1 point. So here number of zeros is 1. So in this example it cuts at, so the line intersects at x-axis at x is equals to minus 3. Therefore the number of zeros is 1. Next is in quadratic polynomial. So in quadratic polynomial, its standard form is ax square plus bx plus c. Here its degree is 2 and number of zeros will be 2 here. So here this shape is called as parabola and this is upward parabola and this is downward parabola, and here this parabola cuts the x-axis at 2 points and here the downward parabola, it cuts the x-axis at 2 points. So therefore number of zeros is equals to 2. Exercise 2.1. The graph of y is equals to p of x are given in the following figure. For some polynomials p of x, find the number of zeros of p of x in each case. So first one, so this is a graph and this is the x-axis and this is the y-axis. So here in this case find the number of zeros of p of x. So the graph here, the graph does not intersect the x-axis at any point, therefore it does not have any zeros. So here the graph, here the line, it intersects at the y-axis. It is not intersecting at x-axis. So the number of it does not have any zeros here. Now second one, coming to the second one. So here is the x-axis and it cuts at only 1 point. So the graph intersects the x-axis at only 1 point. Therefore the number of zeros is 1. Now third one, here this is the x-axis and this is a y-axis. This is upward parabola. Here the graph intersects the x-axis at 2 points. Therefore the number of zeros is 2. Fourth problem. This is x-axis and this is y-axis. Here the graph intersects at the x-axis at the 3 points. This is 1 point, this is 1 point and this is 1 point. 1, 2, 3 points. Therefore the number of zeros is 3. Now coming to the fifth problem. Here the graph intersects at the x-axis at 1 point, 2 point, 3 point and 4 points. Therefore here the graph intersects the x-axis at 4 points. Therefore the number of zeros is 4. Next sixth one is, here in this graph, the graph intersects the x-axis at 1 point, 2 point and 3 point at the x-axis at 3 points. Therefore, the number of zeros is